Morning. All right, so we're getting ready to talk a little bit about limits. Most of this is actually review. I just went through it. And to be honest with you, this shouldn't be a hard stretch. The only thing is we're going to look at a lot of pictures. That's why I needed you to really print it up so that you can see what I see. So hopefully you did. I knew a few of you reached out. I mailed your packets. Hopefully you got it. But we're getting ready to go. So the first thing we're going to do, we have a graph, we have a formula. They give you the equation. They tell you that the whole, right, which is right here, the coordinates are -376, which is kind of good, but we're going to explore it old school way. Let's talk about our pre-calc statements, and then we're going to turn them into calculus statements. So to get you guys ready for the lingo of next year with Miss Erickson. So hopefully you guys are ready for it. Let's just take a look at the graph. Let's look at our first statement. It says as x approaches negative infinity, the graph of f of x goes to. All right, so we want to know as x is getting bigger, where is y going? And as x is getting larger, so going to the right, it looks like it's going to just hit at that asymptote. That asymptote has a y value of 2. So right here, that's going to be your answer. Now, to turn it into calc notation, we're not going to say it like this. We're going to apply limits in there. So it's going to look like this. The limit as x approaches infinity of f of x is equal to 2. So that's how you're going to see it written next year. Okay, and we did a little bit of this this year, so it shouldn't really be a big stretch. Let's look in the other direction. Is x, oh wait, crud. Actually, it doesn't change the answer, but the first one says as x approaches negative infinity. All right, so same idea. As x is going to the left, getting smaller, smaller, smaller. So it still is 2, but sneak in a little negative infinity there. Have mercy on the old lady's eyes here. I do have my glasses on, but clearly I didn't see that. What I can tell you about these copies too, it's very hard to see the negative and the positive, just because maybe the copy quality isn't that great. Just bear with me and make sure you listen. All right, the second one is now going back to positive infinity. So as x gets bigger, it's also going to 2. So it's going to be the same. The only thing that's different is x is going to approach, when we're talking about this guy, positive infinity. And that's going to be equal to 2. All right, now we're moving on to actual x values. So the first two here, we're looking at x approaches -3 from the left and then from the right. All right, -3 is here. -3 from the left is a little bit above 1. Same thing with from the right. Now I'm going to show you how to get exactly that value. We did this in the last lesson. So we want to know as x approaches -3. So we can look, I know a -3 when I pop it in here is going to go undefined. So if you recall from lesson 12.1, we could do some substitution, which gave us the undefined, and then we can look to factor. This actually factors. I'm going to save you the torture. I did it before. It factors into 2x minus 1 times x plus 3 all over x minus 3 times x plus 3. Okay, now these would cancel, and now when you pop in that -3, it's not going to cancel out. You're actually going to get 2 times a -3 is -6. -6 over, -1 is a -7 over -3 minus 3, when you sub it in here, is -6, which gives us 7 over 6, which totally makes sense. Look up here. See the connection? So they did kind of give us that information, but I wanted to show you where it comes from. So as we're going from -3 to the left, it is going to approach the 7/6. In addition, on the right side when we're coming from the right. So this is going to be a 7/6, and this is also going to be a 7/6. All right, so now how do we write this one up? All right, we've seen this before. As x approaches -3 from the left, so you have your -3, and then you put a little negative sign up there. That means from the left. F of x is equal to 7 over 6. As we approach it from the right side, same idea. just a little plus sign up here. And that's also going to be 7 over 6. So if you guys remember, the limit exists here, right? Because it's going to same two places. All right, so now we're talking about a positive 3. All right, so a positive 3, now we're over here. We got a nice asymptote here. As we're going to 3 from the left, so from the left side. So where is it going? It's going down to negative infinity. So the calc notation, the limit as x approaches 3 from the left of f of x is negative infinity. All right, as x approaches 3 from the right, so we're going from the right side, it looks like it's going to positive infinity. So the limit as x approaches 3 from the right is positive infinity. Okay, so based on what you've seen here, look at the question. How might you informally define what the value of a limit represents in terms of the graph? All right, so here's what it looks like. You're going to talk about the limit, and we're going to talk about x approaching any value. They refer to that a lot as a. So a standing for any value. Okay, the limit as x approaches a of f of x, it's the y value. So the limit is the y value, right? We know that. Where is y going? The graph approaches. As x approaches a. So as we're looking, as x goes to some kind of number that they're asking you about, we're talking about the y value, okay? So first page done, not too bad. Now we're just gonna look at a whole bunch of different applications of this. So a lot of it, again, is going to be review and maybe like tidying up some loose ends, some things that maybe you question. I do tend to question things with limits. Sometimes I overthink it, but you know, it's one of those things. It will become second nature for you guys. You just got to get used to it. All right, so we're going to look at the same graph in a lot of different aspects. Exactly what we answered on the first page, we're going to just kind of mess around with using the calculator. I do remember when I was in college, you guys have to understand, when I went to high school, we didn't have a calculator. So, you know, our abilities to analyze were a little hindered, where when the technology really came in full force, the calculator is such a useful technique, especially with limits, right? So I remember being in a class and struggling, like, how do I find, you know, where the limit is, you know, and it was taking me a while. And this one little young chippy next to me, who was probably a good, I'm trying to think, maybe 7 or 8 years younger, she zips through these limits, and I'm like, whoa, how'd you do that? And she's like, oh, I just used my calculator. My pre-calc teacher taught me this in high school, and I was, you know, feeling a little old. So you guys don't realize how nice it is to have that technology. Now, on the AP exam, there are going to be areas where you can't use your calculator. So you can't really lose that mental ability as well. All right, that being said, as I ramble on, all right, we're going to revisit as x approaches negative infinity and infinity, and we're going to talk about it from the calculator aspect. So I'm going to kind of save some time here. I did figure out the chart. Now, when you're looking to do values like this in your calculator, you would type this into y equals, and instead of, like, you could adjust the table. I think I went up by 50s just to mess around, but you could hit second calc and hit number 1, and that gives you a value, and you could just pop in negative 1,000 and it would give you the value. But anyway, I'm going to just fill in the values for you. When x is negative 1,000, popping it into that original equation, you're going to get 1.995. And when x is negative 500, you're going to get 1.99. We're going to get negative 100, 1.95, then 1.91, and then 2.1. So we went from negative to positive here. That's really important. And we jumped from that 1.9 into over 2. 2.05, 2.01, and then 2 when x is 1,000. All right, so we answered this in the first page. So if you want to flip back to the first page, as x was approaching negative infinity, you guys told me the value was 2, right? Because that's what it did over here. But looking at the table, that's pretty easy to see. As x is getting more and more negative, right? I started at 1.9, and it looks like I'm going all the way to 2. It looks like the more I increase my x value, the closer it is to 2. So you're almost able to see it in your calculator as well. I don't know. I like it both ways. I like to look at the graph. I think it's a little easier to see the graph, but sometimes you can't. So sometimes you rely on the calculator. It's kind of like whatever works for you. Let's look on the right side. Now, as x is getting to positive infinity, so as x is getting bigger, look, I started at 2.1, and then I went 2.05, a little less, but at 1,000 it hit 2. So keep in mind, it's not going to exactly hit 2 because there is an asymptote that's like an electric fence, but the limit is going to 2. Okay? So how is that numerical analysis? How does this relate to this graph? Well, as you look, as x approaches negative infinity, which is what's going on here, y is getting close to 2. Right? It's not going to hit it because there's an asymptote, but it's going to get really, really close. And on the flip side here, as x approaches positive infinity, y is getting close to 2 as well. So again, like if you didn't have this graph and you just had your calculator and you threw the table in, you know, it might be easier just to read it off the table. But if the graph's in front of your face, sometimes it's easy to read it off of your face. Good? All right, so now we're going to look at the same aspect again. All right, what we're doing today is we're really looking at the calculator and how it could help us. Same picture, same example. We're talking about approaching -3 from the left and -3 from the right. So this is pretty cool to see as well. I still had that in my calculator, and I definitely hit the value, second calc 1, and I popped in all these values. So I'm going to save you the torture. We're going to hit, let me just turn my page. I'll give you the table. I'm going to change my color up. All right, so at -3.75, I have 1.26. Then I have 1.18, 1.168, 1.167, 1.167, 1.165, 1.15, and then 1.13. All right, so like I said, you know, I didn't just pull them out of the top of my head. I actually figured out ahead of time. All right, so we're looking at -3. So remember, -3 had that hole. You guys recall that it was equal to 7/6. So if we look from -3 from the left side, so that's coming in hot from the left, right? And we're approaching 3. Now, 3 happens to occur right here, -3. Okay, right in that little section. So if you look, check it out. It's kind of symmetrical. It doesn't always have to be exactly symmetrical, but it worked out that way. As you were approaching -3 from the left, right, you got to 1.167, was pretty close. Okay, so 1.167 is approximately, that's 7/6. And then same thing when you came in hot from the right, right? You're going in, and look, 1.167. So that shows us algebraically, like through the calculator, as opposed to having the picture. All right, so a couple of things here. And with calculus, you really have to describe a lot more than you're used to. I know in the past, because I've taught you guys, or not necessarily you guys, but I've taught Algebra 2 and I've taught the pre-calc honors, and kind of, you know, we go through the answer and the answer is what it is. Now you have to go through a little bit more analysis. So you have to be very descriptive and be able to put it into words. I do know a lot of times when I taught geometry and I was trying to come up with a reason, you know, sometimes to get the words right, you know, you might want to think in sort of that if-then statement. You know, if we approach -3 from the left, then we are going to 1.167. It's not exactly precise, but it could help you with the flow of the words. Okay, so what we want to write here, and this one has the same number on both sides, so it's a little different from the one prior. So as x approaches -3 from both, from the left and the right, y approaches 1.167, which, now this is where you get a little bit of analysis in here, which is the y value of the points, and it's going to get fancy, of discontinuity. Remember that? The point of discontinuity at an x value equal to -3. So that's our analysis there. All right, I hope you're doing okay. I hope I'm not chewing your ear off. I hope this is, 15 minutes in. All right, this is going to be a long one, but remember, it's not hard. It's just a lot of in-depth, talking about things. Also, this is the only lesson for the week, so if I torture you for, a little bit extra, remember that's the only thing going on. All right, back to, again, we're looking at the front page, right, that we had before, and we're just looking at it more in depth. We're looking at +3 now from the left and from the right. So a couple of things. We look at R values. We're going from 2.75 to 3.75. So 3, again, is going to be smack in the middle here. So from the left, from the right. Saving you the torture of typing it into your calculator. So follow my lead here. When x is 2.75, you're going to get a y value of -18. Then 2.9 is going to give me -48. 2.99, -498. 2.999, -4998. And then we hop to 3.001, and now all of a sudden I'm at 5,002. Then at 3.01, I am at 502. And then at 3.1, I'm at 52. And at 3.75, I got 8.7. All right, so looking at the table, no graph here. As x approaches 3 from the left. All right, so like I said before, coming in hot, right? You're coming from the left. You're looking at the table and you say, ooh, -18, and then -48, and then -498, and then, oh my God, -4998. So this is getting more and more and more negative. It's not really bottoming out anywhere. It keeps going. It's getting more and more negative. If you did 2.9999, I'm sure it's going to be even more negative. Now, there's no ending point to it, so it is going to -infinity. And if you look at hitting 3 from the right, so coming in hot, right? Here I am, 8.7, 52, 502, 5,002. I wish that was how my bank account grew. All right, anyway, it's getting more and more positive. So this is heading to +infinity. So as we're hitting 3 from the left, according to, if I don't look, according to my values, it looks like it should be going down. Okay, and if I look at 3 from the right, it looks like I should be going up, right, forever. And if you look at your picture, that confirms it. I mean, you guys already know this picture. So how do we write it up? How is it related? All right, we're going to talk from the left first, and then we'll talk from the right. So writing it up formally, as x approaches +3, or just 3, from the left, the graph is approaching -infinity. So what that means is, so the values in the table should be very negative, right, as you head in. And they did. They started at -18, and then all of a sudden you're at -5,000 pretty much. So yeah, they got really negative really fast. All right, so on the right side, as we're coming in here, as x approaches 3 from the right, the graph is approaching +infinity. So the values in the table should be, as you're heading in, they should be very positive, like very large. So very large positive numbers. Okay? Also, a word to the wise, if I was you guys, and I know how people love to burn their school books at the end, I wouldn't be so quick to throw out this information on limits and then ultimately when we do derivatives. So anything, honestly, from 12.1, even the polar stuff is important. You want to keep that stuff in with you. But definitely, this is going to be your opening to AP Calc. You're going to hit limits again. So if I was you, I'd hold on to this. Okay, I would have definitely printed it up and I would tuck it away because you're going to have a good 3 months off, right? Well, I feel like we're going to have 6 months off, even though we're still remote learning. You got to be able to look back at stuff. So it's nice to have this, okay? So don't be so quick to throw it away. All right, so now's a little bit different. We're done analyzing pictures. We're going to talk about this limit existence theorem. All right, let me just make sure we're in here. All right, so talking about when a limit exists, right? Like I said before in the Mean Girls. And there's a couple questions, pertaining to this. So we're talking about discontinuities again. It's been a while, right? You have removable, which involves a point discontinuity. We have infinite discontinuities. We have jump discontinuities. So again, it all relates into this limit existence theorem. Okay, now here's what you need to have, and we've talked about this. So this really should not be a big stretch, but here we are. We're going to write it up as calc-minded people now. So we're going to talk about the limit as x approaches a of f of x, right? So again, we're back to that a. We're saying it exists if and only if and only if, right, the limit as x approaches a from the left, ooh, I don't know why I put a 1 there. It's just a from the left, here, I'll do that, f of x is equal to the limit as x approaches a from the right, of f of x, and that's they're going to say is equal to some value b. Now, what's really, really important, this is something that I struggle with when I forget, that b, so star it, has to be a real number. So we're saying when you look from the left and look for the right, remember with that 7/6, it has to be the same value for the limit to exist, even though it has possibly a discontinuity at that exact point. But it has to be a real number. So like if you were looking at a value, right? Actually, example 1 is going to totally explain that. So let's go right into the example 1. We're going to look at the couple of values. We're going to look at, and this print is tiny. Letter A says the limit as x approaches 2 from the left of f of x. All right, so here's our 2. We're approaching 2 from the left, so it looks like it's going to positive infinity. And then when we look at 2 from the right, so coming in this way, it's also going to infinity. Now, the value of f of 2, not a limit, but the value here, this is undefined. Right? There's no value. If I asked you to find f of 2, you'd be like, yeah, no, Mrs. Thornton, there isn't one. Now, we want to know, does the limit as x approaches 2 exist or not? Why or why not? All right, this is really important. I struggled with this one, just trying to understand, because I say, hey, they're both going to infinity, but it goes back to this star here. B has to be a real number. Infinity, it doesn't have a value. It just goes on forever. So there's no way of saying it's a real number. So the limit does not exist. No, and that's because it has to go to a real number. Now, if you guys struggle with anything, just shoot me a question. It's always good to talk about things. Sorry, you might have been cut off a little bit. Sometimes you guys overthink things. You guys are so smart and so brilliant, and sometimes it's hard to understand a concept. Just ask me. Send me a remind. Send me a message on Schoology. Send me an email. Anything you don't understand, I'll explain it to you, and I promise I will not make you feel like an idiot. All right, so next graph. Example 2. Now we have a removable, right? The point here. Now, sometimes there's a point that's filled in, and sometimes there's not. Sometimes it's just flying with a hole in it. All right, so now if we're looking at 2 from the left, so we're coming in. Now, I know the value of 2 is here, but as I'm approaching it, you got to ignore this. Coming in, it looks like it's going to a y value of 2. And then if I look from the right side, so now I'm heading, in from this way, it's also going to 2. However, the value at 2 is a -3, right? Down here, the exact value is that closed circle. So the idea is, yeah, f of 2 might have had some different value, but the limit here does exist because these two numbers match. So yes, the limit exists, and it's 2 because 2 from the left and 2 from the right go to 2. Okay? All right, so that's how you deal with a point discontinuity, right? Removable. All right, this example 3, that's a jump, remember? So like with the jump, there's a lot in between, okay? And it picks up, okay? It's not continuous, right? It would go jump, right? It's not just like here, I'm missing a point and I keep going. Okay, so looking at the limit from 2 to the left. Now, I know it's a little, light in here. 2 from the left, 2 from the right. All right, so as I'm heading into 2 from the left side, I'm ignoring what's here. I'm not even looking at it. It looks like it's going to 3. But if I look coming in from the left side, now my value at 2 is heading towards a -3. Now, the actual value f of 2 is the closed-in circle. That's a 3. So the question is, does the limit exist or not? And you're going to say no. And that's because the limits at 2 from the left and 2 from the right are different. So the limit does not exist. Okay? So, how you feel? Good stuff, right? All right, I do believe this is... we got 3 more pages. All right. I know that we are 27 minutes in. Hopefully the rest fly by. Hopefully I'm done by 35 and your torture for the week will end. All right. So what we're doing now, and this is really important, we're going to come up with a definition. Does it have to be defined in order for the limit to exist? Draw and explain 2 different graphs to justify your reasoning. All right, so remember, like f of 2 didn't have to exist, right? So let's see. Let me explain that again. Does f of a have to be defined? No, it doesn't have to be defined. As long as it's going to the same spot, it could have a limit. But there can also be a situation where it's undefined and the limit cannot exist. So let's talk about... where the limit does exist, okay, and f of a is not defined. So that would be a case where, I'm just going to do some dashed lines here, okay, the limit exists, but f of a is not defined. All right, so we're going to draw a little graph here. Switch up my colors. Okay, let's go to like a red. Let's do some Christmas colors. All right, so let's say we have some point A, okay? And we're saying it's not defined. So I'm definitely going to put a hole here. And I am going to show where we can have a limit. So remember, the limit means from the left side and the right side, it's heading to the same point. So I'm just going to make it simple. So from the left, from the right. So if I'm looking from the left, I have a y value here. If I'm coming in from the right, I have the same y value. So even though a is not defined, there is a limit, okay? Now, looking at where another case scenario where the limit does not exist, DNE, but f of a is not defined as well. All right, so where would you not have a limit and f of a is not defined? All right, let's do another picture. Remember, you don't have a limit when you are going to two different y values when you're looking from the left and right. So the best way to describe this is a like a jump discontinuity. So let's see. Here's our A. We're going to have an A. We're going to have an open circle, and we're going to have a closed circle. So let's say coming in from the left, right, I'm here at this y value. And then I jump and I go like this. So coming in from the right, I'm going here. All right, so they are not headed. Say like this was 1, this was 2. So from the left, it would be going to 2. From the right, it would be going to 1. 2 is not equal to 1. Therefore, your limit does not exist. Okay, so removable point discontinuities, those are going to be where you have your limits. Jump ones, those are going to be where you don't have your limits. All right, so here's what I'm going to do now. This is great. I have just a table of an exponential function. I don't have the graph. We're just going to quickly find the limits, okay? This is fun. All right, so no picture here to confirm anything. All right, so looks like I got an x value -9 all the way to 9. So my negative infinity would be this way, and my positive infinity would be this way. All right, so as x is heading to negative infinity. All right, so as I'm getting more negative, look at your values. Your values go from 3 to 9 to 33 to 513. They are increasing rapidly. So I'm going to say as x approaches negative infinity, which is going out, I am going to positive infinity. All right, let's look at the next one. X approaches -3. All right, if there is a value at -3, that's where it's going to approach. That's what you're going to get. So as x approaches -3, you have a y value of 9. So nice and easy. All right, same thing here. As x approaches 1, well, do we have a value at 1? We do have a value at 1. It's 1.5. So as x approaches 1, 1.5 is going to be where your y value is. All right, last but not least, look at this. This is interesting. As x approaches positive infinity. So as it's getting larger, it's going from 9 to 3 to 1.5 to 1.25. When it's 9, it's 1.002. So it looks like it's going to top out at a positive 1. That's where we're headed, according to our table. Okay? So that was easy. It was an exponential function, so it's continuous. This next one, we have a rational function. This is more interesting because we have some places where it's undefined. So like when we looked at B and C, it was cut and dry. We knew what those values were because they existed. Here they don't exist, so it's a little bit more guesswork. All right, so first one looks like we're looking at our table as x approaches negative infinity. All right, so we are looking as it goes to the left. Okay, so now it went all the way from, you know, let's check it, -1. It's at 2001, and now all of a sudden it went to, and it went to a 1.002. So it went from a -1 to a -1000 in the x, and it went from 2000 all the way to 1.002. So I'm going to say my limit is going to be 1. All right, let's take a look as x approaches -1 from the left. Now, this is important because at -1, it's undefined. So as we're coming in from the left, it looks like it's going from the 1 to 2000. So it looks like it's doing a steep jump here. So I'm going to say this guy is headed towards positive infinity. All right, now we're looking at -1 from the right. All of a sudden, -1 from the right, I went from -1 to -1999. So I got real big, real quick. So that means in the negative direction. This guy here is going to head to negative infinity. Okay, another place where we have some issues. As x approaches 2. All right, so as x approaches 2, you got to look here. This is the first time we have just a number. Okay, we're not heading from the left and right per se. We're looking at the 2, the limit at 2. Now, I'm not defined, so that's an issue. So I'm going to look at the left of it, and I'm going to look at the right of it. And if you guys notice, 0.333, 0.334. All right, it's coming in at the same value. It's coming in right at about 1/3. So that's the limit there. So you have to look left and right here. Look from the left, look from the right. If they're heading to the same value, that's going to be your limit. All right, next one, as x approaches positive infinity. All right, so it's getting bigger. It's at 0.334 at an x value of 2. When you have an x value of 1,000, which is a heck of a ton bigger, now all of a sudden it's at 0.998. So I'm going to say it's heading to 1. Now, the last one says the limit at -1. All right, the limit at -1. Remember, I said look left and right because it's undefined. We're at a positive 2,000 here. We're at a negative 2,000-ish here. They're heading to different directions, to infinities, positive and negative. The limit here definitely does not exist. Okay, different from over here. All right, that was good. That was quick. All right, next thing we're going to do, we're going to look again at the graph, but this is a cool graph because this is got a whole bunch of stuff in it. It's got some like a jump, right? It's got a point discontinuity. It's got infinite. So it's got a little bit of everything. So I like this. I actually left something like this a while back when we had a sub, and I think Nick, you had texted me about this sub when my husband was going into surgery, and out of the 5 Nicks, it would be Nick P that texted me on that one. So anyway, looking here, we have this crazy picture, and we're just going to fill in. So I want you to take a sec, maybe pause the video, and see if you can figure these out. I'm just going to keep talking, though. As x approaches -3 from the left. All right, -3 is here. I got an asymptote. From the left, it looks like I'm heading to positive infinity. As I head, looks like a -5. All right, so let's see. 1, 2, 3, 4, 5. All right, as x approaches -5. All right, so now remember, you're looking from the left and the right when it's just a number. It looks from the left, it's going here to a value of 4. And from the right, looks like it's going to a value of 4. So the limit as x approaches -5 is 4. All right, now we're hopping to a -1. All right, as x approaches -1, all right, look from the left, look from the right. It looks like that's also going to -1. All right, back to just -3. All right, as x approaches -3, so when they're talking about the specific value, not from the left and the right, but now we have an asymptote, so we got to check it out. We're going from the left, we're going to positive infinity. From the right, we're going to negative infinity. Heading to 2 different places definitely does not exist. Okay. Where are we at now? We're at letter D is 2 from the left. All right, 2, when x approaches 2, from the left. All right, so it's heading to a y value of 1. And now we're looking at 2 from the right. So we're heading in this way. 2 from the right looks like it's going to a positive 6. So the limit as x approaches 2, remember, we're heading to 1 from the left to 6 from the right. Those two numbers don't match. Therefore, your limit does not exist. All right, as x approaches negative infinity. All right, looking all the way to the left. All right, looks like it's getting very close to that asymptote. That asymptote is at 2. And then from the right, all right, we're looking at infinity. Okay, so as x approaches infinity, so now as x is getting bigger and bigger and bigger, this is going up towards positive infinity. Yay. Wasn't that fun? That's fun. All right. One more. One more crazy picture, and then you guys are free and clear. So again, we got a little bit of everything, right? We got some removable point discontinuities, one with a value, one without. We've got some asymptotes here. This is a good one. All right, so let's see, -3 from the left. Okay, so my -3 is here. From the left side, it looks like it's heading to a y value of 0. All right, next one. As x approaches -6. Well, where the heck is -6? 1, 2, 3, 4, 5, 6. All right, so it's heading to a value from the left and from the right, which, let's see, is here. That corresponds with -4. Okay, so that had a flat out value. All right, as x approaches in letter C, -1 from the right. All right, -1 from the right. It looks like it's going to a value of 2. All right. I feel like I'm jumping all over the place. All right, -3 from the right. Okay, so this is going with A. -3 from the right. As x approaches -3 from the right. That's also going to 0. Okay. Let's see. Letter E. Oh, this was a weird one. All right, x approaches 4 from the left. All right, so this is 4. And, you know, we're looking here from the left. Now, it doesn't approach 4 because it stops here. Okay, so there's no value as it's getting closer to 4. So that's a weird one. Okay, it doesn't exist because there's nothing there. So nothing as it gets close to 4, right? It dropped off the face of the earth, right? There's nothing there, so I can't say it's approaching anything. It basically stops, doesn't include, but stops when we get to an x value of 3. So that's a little funky. And that happens, remember, these are called piecewise. We're gonna actually like graph a bunch of piecewise functions in the next lesson, but again, that's a week from now. So, you know, take it all in now. All right, letter F says 4 from the right. All right, so this is different. So 4 from the left, there was nothing, but 4 from the right, it is heading to negative infinity. So there is a value there. All right, 3 more, speed it up, and we'll just chat a second more, and then you're free to go. All right, so the limit as x approaches 4. All right, as x approaches 4, right, there is no value at 4, so we have to look at the left and right limits. There's nothing on the left. To the right, it's going to infinity. So, like, there's a lot of nothing going on here. So this definitely doesn't exist. All right, so now we're hopping to -4. All right, -4 from the right. All right, -4 from the right looks like it's going to a value of, that looks halfway between -2 and -3. So I'm going to say -2.5. And the limit as x approaches -4 from the left. All right, coming in hot. All right, it's approaching a value of, oh my God, what is that? -6? All right, so if I asked you the limit at -4, right? They didn't ask you that, did they? I don't see it up there. No, they only asked about +4. So the limit at -4 is also going to be a DNE situation because these numbers don't match. Okay, so a lot of old combined with new, clearing up any issues you have. Remember, for a limit to exist, left side and right side have to be heading to the same number. Just be really careful. Take it all in. Please, if you have any questions whatsoever, you have to ask me, no matter how minor or how stupid you think it might be, or if you're struggling on how to understand something, you have to know this stuff cold for next year. So I believe the next 2 sheets are like a homework. All right, so I would honestly suggest you do them all. So what is there? Day 1 and day 2. Okay, and then that's it. And then it goes on to the next lesson. So like page 19 and page 20, if you're looking at the bottom right, I definitely suggest doing them. I suggest checking them with the key I posted just so you're in a good spot. I hope you had a great Memorial Day weekend. And I hope that you enjoy this week. Hopefully it's shorter than you think. All right, and I have I believe, a Castle Learning on this one. So I'll let you know in the folder. All right, 45 minutes of torture, all apologies. But again, the only lesson for the week. So talk to you soon.